Hello guys, today we are going to be talking about Kirchhoff's laws. Today we will be discussing about uh, second Kirchhoff's law. First Kirchhoff's law we can get, and it is followed from uninterruption current and flux. Second Kirchhoff's law we can get from solving basic equations of electromagnetic field. For doing it, let's look this picture. This picture is a simple circuit, consists from electrical motive source with alternate current. This electromotive source consists electromagnetic field strength, which function from time. And next parts this circuit are conductors on top and on the bottom, and the capacitors on right. We can write equations for this circuit. These equations will be consistent from next parameters. These parameters are first current. Now we will be writing equation for one part. One part is a electromagnetic electrical motive source part. This current, which in this circuit elsewhere similar as followed from first Kirchhoff's law, and this current we write letter E. It equals this symbol is conductivity. Conductivities are different in these different parts. This is conductivity in first part is gamma with subscript 1 times by with braces this electrical field strength consists from three parts. First part is side electrical field. This part only in first part of the circuit of our circuit. It is erase little and write 1, erase again, S plus next part of electrical field is E with subscript P. Subscript P is it means that next E with subscript E. these parts of electrical field are potential part with P and inductive part with E. E means inductive or inductance part. Inductance, right? It's right. Inductance. Then we multiply this. This equation is vector equation, as we can see, because all these conceptions are vector conceptions, vector parameters, and multiplied, scalarly multiplied for cross section this part 1 of our circuit, and we get current which is along our circuit elsewhere. And for next part is conductor of our circuit, we can write as similar gamma with subscript 2 multiplied by electrical motive source. Electric flux is absent on this part, and but electrical field potential is present, and electrical field which induction part is present too, and we write it and multiply it by cross section. Cross section is second. Cross sections are second part with subscript 2 as right, and we write third equation for this capacitor. E equals here here we have exact conductance which presence in previous parts of our schemes, previous two parts. This we have, in this part we have permittivity mark designated by epsilon 0. Epsilon is permittivity in the Occam, and we can multiply it for E subscript P plus vector E with subscript I, parts potential and induction, and cross section S3. This is a unit vector, and because it vector as normal perpendicularly cross section, and we can write S vector equals cross section vector times simple S, no vector. no vector symbol. And if we multiply these parts on unit of length, this unit is vector to we will get next equations. Equation for first part we can write as such: e s plus e p plus e I and d l vector equals d l. Here we are, this equation multiplies on dl, dl simple without vector, and here is I, which marked current, with designated current divided times by divided by S1 here, and conductivity is gamma 1. This is unit of conductivity, and we have equation for first part for electrical motive source, and next equation we will write for second part our circuit is conductor part, and right we will be writing as similar how first part, but without es. We write ep plus e. So dl vector equals dl e divided by s 1 second, and here second 2 for second part, for third part, for capacitor part of our circuit. We will write next equation, third equation. Here we have similar parts of electric field, strength P plus E how I d L equals, here attention, this we can write how dl E and divided by epsilon and S3. And I have forgotten right here this, sorry, erase. Next here will be such multiplier d by b d divided by dt. Here changed, if here we have capacitor, here changed all electric field strength, uh, 0. And we have, if we write d, operator d time d divided dt operator, write how p, we have p here too in denominator of this right part, right right part of third equation, and it is written exactly. And next, and I forget right here, d l equals unit vector n 0 dl, and if we remember this, we can understand how in these equations we get dl vector. Normal vector remains, and times dl times on dl, and divided on vector s. How this is, if we divide it by s, we have a normal vector in these parts, and multiply by dl, we have here how it happened. So next we will add all equations, all our three equations, with by parts, right by right, left by left, and integrate. If we will be integrating these three parts, and write how it happened, how it following. Integrate by L, integrate by L, by length. L is length, as we remember. And first integral, E side integral dl is, here we write how E from T is electromotive source plus integral by L E potential 1, here is 2, 3, and 1. Sorry, I have forgotten right how it is. E P2, and memorize only now, plus E P3 dl dt is wrong. We will write here dl and vector, all vectors. This part is equal 0, because potentials in this part scheme, all parts this scheme are 0. potential parts are 0 plus a zeros plus integral by L. Next part is induction part. E 1 3 2 1 plus E 2 plus E 3. We add and integrate it by L. Here is integral from sum equals sum of integrals each sum separately. This integral equals minus d flux divided dt. It is derivative of flux by time, and all part this part equals, we can write it equals integral. This part is no vector, it part is just L, just without integral. And we can write here write current is we carry from integral side, and no one here is we can write no one. Here is dl divided by stop, wrong, stop, all wrong. Now we can write in the braces similar like here, like in the left part of our equation. Similarly, we can write 1 divided by S1 gamma 1 plus 1 by S2 gamma 2 dl and plus integral e by p, not forgotten, not forgotten, and here we can write dl divided by epsilon 0 S3, and finally we can without even equal sign we can write here equation from second Kirchhoff's law. It seems like E from T equals carry parts of this equation and supply for these places, and we can get how this part equal, we write simple, and then this part we have write as this part as L divided by conductivity, controversial part of conductivity is resistance. And we can write how air resistance 1 plus resistance second by current plus carry this part to right from left, and df dt plus this p is, we write this part how 1 by capacitance and integral and times integral current dt. This such happens, and this is second law of Kirchhoff. All right, lesson and goodbye.